Hi all, we are going to go through F1 and F2 cross for a dihybrid cross. So we're going to start with picking our organisms. So let's just say we're going to pick fish. So we'll draw some fish, we'll have parent fish, we'll have a black-bodied fish, and this is going to be a dominant trait. And this black-bodied fish is also going to have dominant trait for spiky fins. His mate or her mate will be a blue-bodied fish. Now the blue-bodied fish is going to be recessive. So it's going to be carrying both recessive genes. So it's homozygous recessive for both its body colour of blue and for its fins, which are rounded. So there's their phenotype. Let's write the genotype underneath. So first let's pick a letter for what we're going to do. Remember, it's always best to try and not fail. To try and pick a letter. A letter that is, you can tell the difference when it's capital and when it's lowercase. So something like an S would be no good. Something like a U would be no good. But we're going to use a B now for body. So this is dominant, so it would need two capital letters because it's homozygous dominant. And the blue one would be recessive, so it would have two lowercase b's. The fins will choose F because we can tell the difference between an upper and lowercase f. So again, that male there that we've selected is homozygous dominant, so two capital letters F, again, for his fins. And his mate, the female, is recessive, homozygous recessive, so she'd need two lowercase f's. Okay, so if we're not going to bother looking at the gametes or going through a cross for these using a Punnett square, because this would be quite straightforward and something we would have done in class anyway. But all of their offspring would be heterozygous for both of the genes we're looking at. So they would always have a big B and a little b, and they would always have a big F and a little f. They would show the dominant trait, remember, because they've got that capital letter, but they are carriers, as we call them, or heterozygotes. Okay, so now we're going to do some incest. We're going to breed two offspring, two siblings together. That's so far our F1 cross. That's what we got. Now we're going to do the F2 cross, breeding two siblings together. So this is where we're going to pick what the potential gametes could be. Remember, both parents have the same genotype and the same phenotype. And we're going to see what phenotypic ratio we come up with. So, the possible gametes, remember there's 4 possible gametes, will always be from their genotype they have. So, let's have the first gamete would be using a big B and a big F. That's a possible combination. And then another possible one is a big B and a little f. Third one would be a little b but a big F. And the fourth one would of course be both the lower cases. So a little b and a little f. Okay, remember both parents would have these possible gametes. So both sides of our Punnett square, both across the top and across the bottom, we would need to fill out with these 4 possible gametes. So we'll fill those out now. So remember, this is a dihybrid, so we're looking at 2 genes whilst we're doing this. It's not multiple alleles, it's not genes for the same, it's not alleles for the same gene, it's 2 different genes we're looking at. So body and fin. So they're both exactly the same, so it doesn't really matter which parent is which. You could be really specific and put which parent is which, so dad on the top and mum across the bottom. But it doesn't really matter. So let's fill in our Punnett square. So remember, there's 16 outcomes. So I'll start filling this in now. There's 16 possible offspring. So we know eventually the whole ratio should add up to 16. So remember, like in that top left one, as I filled in, you always want to keep the gametes paired up. Don't put BF, because it doesn't work. You always put them together. We need to be able to read the genes. Remember, they're on 2 different chromosomes, but paired up, one from mum, one from dad. So we'll go work our way through this. And we'll keep filling it up, keeping those pairs together. 15 and 16. So we filled in our 16 squares, so remember your ratio should always add up to 16. So if it was 8 to 8, that would work, it would be 16. But if it was 12 to 7, it wouldn't work. We obviously counted it wrong somehow. So what we're going to do is we're going to have a look at each of the offspring. We're going to see if they have the dominant trait for body and the dominant trait for fins. So I'm going to circle these. So for example, that one has at least one capital B, it has 2, and at least one capital F, again it has 2. I'm going to go along all of them now, circle those that have a capital B and a capital F. That's going to be the first part of my ratio. Excuse me. So we're going to go through and look for all of those that have at least a big B and at least one big F. Right, okay, there's that one. And the next one. Okay, none of the others have a big B and a big F. So now I'm going to change my colour. So now I'm going to look for those that just have a big B. So I've already circled those in red. So for example, this one I'm circling now has just got a big B. It's got Fs, but they're not capitals. So it's only dominant for the B. Here's another one, and one more. And now I'm going to change my colour again. So now I'm going to look for those that just have a capital F. So let's circle those now. So there, capital F, 2 lowercase b's, and at least one capital F, and at least one capital F. Which leaves us with one on its own. So now what I'm going to do is count up and have a look at the F2 phenotypic ratio. So if I count all of them up, so this is the phenotype, also known as the phenotypic ratio. So the ratio for this is add them all up. So the reds, there's obviously more of them first. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So there's 9 of them. So 9 of the individuals would carry both dominant traits. Now let's have a look at the next one. 3 of the individuals would carry capital B's, so would have a dominant black body, but would not have those dominant spiky fins. The next one, there's 3 more of them. They'd have the blue body, but they would have spiky fins. There's 3 of them. And that leaves one on its own, one individual that would be homozygous recessive for both genes. So this gives us a 9 to 3 to 3 to 1 ratio. And does this add up to 16? It does. So, this is an F2 cross for dihybrids using 2 genes, so it's a dihybrid cross. It's an F2 cross, and it gives us the phenotypic ratio. It always gives us a 9 to 3 to 3 to 1 ratio.